In this video, we will discuss segment addition and finding the length of segments. First, let's review the segment addition postulate. So the segment addition postulate states that if 3 points A, B, and C are collinear and B is between A and C, AB, so if you look over here, this little segment AB plus BC, so the other little segment, combines to make the length of the full segment AC. And a way of thinking of this is that we have little plus little equals big, because the first little segment right here plus the second little segment combine to make the length of the full segment or the big segment, which we can refer to with our formula as little plus little equals big. In this example, it says find the measurement of each segment. Assume the figure is not drawn to scale. So the first question asks us for the length of EF. So we could call this X. Now, based on what we know, using the concept that it should be little plus little equals big, the little segments we have are EG, which is our first blue segment here, plus the second little segment, which is GF, should add to equal the whole big segment, which is this full length of X. So equals our big, which is EF. Now, substituting the values that we have, we know that the length of the first little segment is 2.5. So I could say 2.5 plus the length of GF is 2.8 equals the length of the big segment, which is X. So it equals X. Now from here, you're just solving a problem. If I were to solve this case, I just have to combine the 2.5 with the 2.8, which gives me a value of 5.3 inches, which is our final answer. Now for the next example, it asks for the length of PR. So I'm going to call that value X. If I'm using this little plus little equals big idea again, my first little segment is the length of this PR, which I can call X. So I can call this PR or X plus the next little segment, which is this segment right here, which we know has a length of 3.7. So it's RS, or in this case, 3.7, equals the big segment, which is this full length of 5.8. So it equals PS, which I could call 5.8. Now, if I wanted to solve this problem, I would just subtract 3.7 from both sides. And when I do 5.8 minus 3.7, it gives us a value of 2.1. So our answer is 2.1 millimeters. In the next example, we begin applying algebra to solve for our missing length. So the problem says if dt equals 60, find the value of x, then find ds and st. Now, when we are doing any problems in geometry, one of the most important things that we have to do is we have to add in information as it's given. So the question here gives us that dt is equal to 60. So I need to label that dt has a length of 60. Now, if I want to solve for x, I'm going to apply my segment addition postulate again. So we know we have the little segment, which the first little segment is this ds, which has a value of 2x minus 8. So I can say I have 2x minus 8 plus the other little segment, which is st, which we know has a length of 3x minus 12, equals the big segment, which we know in this case has a length of 60, as given to us. Now we just have to solve like we would a regular equation. So first I would combine my like terms. So if I combine like terms, I would get that I have 5x minus 20 equals 60. I would add 20 to both sides. So you would have 5x equals 80, and then divide by 5 to get x equals 16. Now this answers the first part of the problem. However, this question is now still asking for the value of ds and st. So if I want to calculate, we know that ds, as asked for here, is represented by 2x minus 8. So instead of writing 2x minus 8, I could rewrite this so it becomes ds is 2 times our value of x, which we said was 16 minus 8. And when you plug in the 2 times 16 minus 8 in your calculator, it gives you a value of 24. So ds is equal to 24. Now for st, we knew from up above that st was 3x minus 12. So if I want to find st, it's going to be 3 times my value of x, which we said was 16, minus 12. So if I do 3 times 16 minus 12, gives me a length of 36. So I could say st equals 36. So now, since I have this, I have all my information. So we have that x is equal to 16, ds is 24, and st is 36. This part over here where you're finding the lengths is one of the most important things that you are checking for in geometry, because oftentimes we forget this part of the problem. We need to make sure that we're always going back to check for it. Pause the video and try this example on your own. Now in this example, as we read it, the first thing we see is it says that EG equals 100. So we need to make sure we label this on our diagram. So if I were to move over here, I can take this and label it right at the bottom of the segment. Now the next thing we need to do is we need to set up our equation. So we know that it always should be in the form, so we have that it's the little plus the little equals big. So if we were to do this in this example, my first little segment would be the length of EF, which is 4x minus 20. My next little segment would be FG, which we know is 2x plus 30. And my big segment would be EG, which is 100. So if I set this up in an equation, I have my little segment of 4x minus 20 plus my other little segment of 2x plus 30 equals the big segment of 100. Now to solve from here, we combine the 4x and the 2x to become 6x, and the negative 20 and the 30 to become 10. Then I would subtract 10 from both sides to get 90. So you have 6x is 90, and you divide by 6 to get x is 15. And remember, the last thing we have to check is that we're finding everything the problem is asking for. So this problem is also asking for the value of EF. So if I plug in the 15 into my value of EF, it gives me a value of 40. And similarly, for the value of FG, if I plug in the value of 15 in for x, it gives me a value of 60. So our final answers are x is 15, EF is 40, and FG is 60. Now let's talk about some additional terminology with segment addition. Congruent segments are defined as two segments with the same length. And the symbol that we utilize for this is this equal sign with a little squiggly above it. So if two segments have the same length, then these segments are deemed congruent. So rather than just saying this means that they have their lengths are equal, that also allows us to say this is the congruent statement that we would use. This would be our congruence statement. Now, in order to indicate that two things are congruent segments, we have to use these little tick marks, which we call our markings. So, for example, it says if two segments have the same number of markings, then they are congruent. To indicate that they are congruent, you give them the same number of markings. So in a problem such as I have here, because these two segments are congruent, I can give them these two markings to mean that these are congruent to each other. Similarly, let's say, for example, I had some other problem, like let's say I had this triangle here, so let's call this L, M, N, and I had another triangle, X, Y, Z. If I were to give, I could give this one 3 markings and this one 3 markings to show that XY is congruent to MN. I could use 1 marking and 1 marking to show that LM is congruent to YZ. And I could decide to use 5 markings if I really wanted to 5 markings over here to show that XZ is the same as LN. But the idea is as long as they have the same number of markings, they're deemed congruent. So in this problem, from the diagram, we can conclude that PQ is congruent to QR. Now, if these two segments are congruent, this allows us to say that the length of PQ equals the length of QR. So if I know the PQ is represented by 6x minus 7, it should be equal to QR, which is represented by 5x plus 1. So now I would just solve like I normally would. So I can bring all my x's to one side by subtracting 5x. So I get x minus 7 equals 1. And then I could add 7 to both sides and solve to get x is equal to 8. Now the midpoint of a segment is the point that divides the segment into two congruent segments. A midpoint, a line, array, or any other segment through a midpoint is said to bisect the segment, and that's a very important word. The idea of bisecting a segment means that we are splitting into two congruent parts. So here, B is the midpoint of this problem. And because it's the midpoint, these are congruent, so you could say that AB is equal to BC. For this example, it says C is the midpoint of AB, find AC, CB, and AB. Now, based on the fact that it's the midpoint, we can conclude that C splits us into two congruent parts. So AC is congruent to CB, which allows us to say that AC should equal CB. So if I substitute, the value of AC is 2x plus 1. So I could say 2x plus 1 should equal the value of CB, which is 3x minus 4. So if I wanted to solve, I'd bring all my x's to one side. So if I, let's say I decide to subtract 3x from both sides, so I get negative x plus 1 equals negative 4. Subtract 1 from both sides, so I get negative x equals negative 5, which gives me that x equals 5. Now, if we look back, we didn't solve the entire problem. The last part of this question is asking for the length of AC, CB, and AB. So if I want to find the length of these, I'm just going to plug in the value of x into the original expression. So first, for AC, I take my value of AC from here, and I substitute the 5 for x to give me 11. For CB, I take the expression 3x minus 4 from here, and I substitute the 5 to get 11. And then lastly, I can add these two together, so we know that this has a length of 11, and this has a length of 11, so the length of AB is 22. And this is almost a secondary check for us because it makes sense that AC and CB should be the same since it is the midpoint and makes them congruent. So our answers would be that AC is 11, CB is 11, and AB is 22. In this last example, it says that Z is the midpoint of XY, and XY equals 27. So using the fact that XY is 27, we know that this whole length is 27. Now, we don't know what the length of these are. However, because it is the midpoint, I know that they are congruent. So rather than just calling them question marks, I can give them a variable name. So I can decide to, instead of calling this x, the question mark and question mark, let's say I decide to call it x and x. If I were to use segment addition now, it's still that idea of little plus little equals big. So in this case, our first little is this segment x plus the second little is the segment zy, which is x, equals the big segment, which has a length of 27. And if I solve this, I get 2x equals 27, and x equals 27 over 2, which we can leave as a fraction in proper form. Now, the value of xz is what the question is requesting here. However, if I look back, based on what I have here, the value of xz is just this value of x right here. So the value of xz equals 27 over 2. So this problem gives us an example where we are using a midpoint to solve, however, we're using the midpoint in combination with segment addition.